Hey everybody, good afternoon. Thanks for coming out to this session. This is ENT332, getting started with serverless computing using AWS Lambda. My name is Chris Munns. I'm joined here by Nikki Joshi from Capital One, who's going to talk a little bit later about some of Capital One's journey towards using serverless. But first I'm going to talk a little bit about Lambda and about some architectural concepts, how you can get started using Lambda, including some of the things that you probably already heard today during Werner's keynote. So again, my name is Chris Munns. I'm currently a senior developer advocate for serverless from AWS. Been at AWS now for a little over 5 years across a number of different roles. But previous to my time at AWS, I was pretty much a traditional sysadmin, IT, DevOps, operations type of person. But in the last 2 years or so, I've kind of seen how serverless is completely changing the way that people think about building applications and actually kind of replacing a lot of what I did in my early years of my career. So really excited about serverless and definitely see it as the future of application development. So why are we here today? What is this serverless thing? What is Lambda? Again, this week you've probably seen and heard a whole lot about Lambda, a whole lot about serverless. And it's not just because we wanted to just only talk about this. It's because what we're seeing across the industry is just an unbelievable interest in serverless architectures and applications. So what does serverless mean for us here at AWS? It kind of comes down to 4 kind of key characteristics. The first is that there's no servers to manage or provision at all. This includes nothing that would be bare metal, nothing that's virtual, nothing that's a container, anything that involves you managing a host, patching a host, or dealing with anything on an operating system level is not something you should have to do in the serverless world. It should automatically scale with usage. So as requests come in, whatever we're doing on the back end should be able to automatically scale for you so that those requests can be responded to. Going along with this is never having to pay for idle. So idle comes in when people have to do things like capacity planning. So today in many enterprise organizations, they are less than 20% utilized on most of their infrastructure. This means that they have 80% of their infrastructure sitting idle that they're spending money on, not getting any value from it. And so with serverless platforms, you never are paying for idle at all. That's one of our key characteristics. And then lastly, availability and fault tolerance built in. So here at AWS, we have this concept of regions. Regions are made up of availability zones. In the world of serverless, you should never have to think about making things multi-AZ. That's just going to be inherent and built into the products that we're going to talk about. So now when we talk about what a serverless application is, it's typically made up of kind of 3 components. Some sort of an event source, AWS Lambda, which we're going to talk a lot about here, and then whatever it is that Lambda might be talking to. So whether this be a database or data store, another API endpoint, some sort of other service that it might be interacting with, or it could just be that your business logic is completely self-contained in that Lambda function and it's not actually talking to anything else. But effectively, this is what a serverless application looks like just from the very, very high level. Now, Lambda is a compute product, so it is actually kind of in the same vein as EC2 and ECS and things like Fargate, which we announced this week. It helps basically manage compute resources so that you never have to think about it. And what happens is we run very, very massive fleets of compute resources, and when an event source is invoked, whether it be from a change in a state, a request to an endpoint, or a change in some sort of resource state, what we basically do is look at how your Lambda function has been configured by you, take your application code, bring it down into our compute environment, execute that Lambda function for you, and you only pay for the duration of that function. And again, there's no resource management that you think of. There's no need for you to have a certain number of hosts sitting around waiting for traffic. It all taken care of on our side on the fly. So serverless is a very, very real thing. Again, there's kind of a reason why we've been talking about it so much this week. This is kind of a fun little eye chart of all the organizations that have been publicly talking about their usage of serverless on AWS. And so these are everything from fairly old school traditional enterprises to very new startups, and again, kind of everything in between. Lots of different use cases. These are all production workloads that we're talking about here, not just dev and test, not just exploration. When it comes to all the different use cases these companies are doing, we find that there's basically kind of 6 big buckets that we can put those into, roughly. The first is web applications. So we're seeing people moving towards things like static websites, whether they be done with, say, reactive frameworks or things like Vue, things like single-page applications, where you're going to use Lambda and something like API Gateway behind the scenes to power the business logic of that web application. We also see this with backends, so things like true microservices that exist inside of an organization as part of some sort of application workflow. Data processing, which is actually the biggest use case that we see our customers using Lambda for today. Things like stream analysis, batch processing, MapReduce. There's a lot of big data digesting that goes on inside of Lambda. Chatbots, changing how companies are thinking about interfacing with their customers, interfacing internally. We see chatbots show up all over the place. Amazon Alexa. So when you ask Alexa to do something, the fulfillment of what it is that you're asking Alexa to do is very often run on a Lambda function. So I believe it was back in October we said that Alexa had something like 25,000 skills. Many of those skills are actually serverless. And then lastly, where many people kind of dip their toes into the serverless applications is IT automation. So being able to take a Lambda function and attach it to one of the many development and management tools that we have at AWS, or interfacing with it for all sorts of different things. I actually had a customer that was using Lambda to manage on-prem networking equipment, built an API in front of on-prem networking equipment. So these are kind of the main 6 buckets that we see people use. Again, there are some things that would exist outside of it, but for the most part, this is representation of all that. Now, a little bit more here about Lambda. So what we've seen over, say, the last 5 or so years is this move towards microservices. And then we're seeing microservices start to become event-based. So what this is changing the dynamic of how applications are built and how you think about logic and workflow into those applications. What we find then is that event-driven compute aligns very, very well with functions as a service-based application models. And then Lambda sits at the core of this, which is a serverless functions as a service service. So again, completely managed, completely kind of abstracted away from you in an event-driven model, functions as the paradigm for how you do application development. So now with Lambda, how do you work? How do you do things with it? So, and actually now this slide is out of date as of this morning, but today 4 languages that are supported inside of it. So we've got Node.js, Java, Python, C#. Soon we'll have Go in a couple of weeks. And then C# or .NET Core 2 also coming out soon. And now with this, you can bring your own libraries. So you can bring in things like NPM packages or pip packages, Maven, NuGet, depending on, again, your language that you're using, standard programming models that you would build any sort of other application in. With Lambda, there's basically just kind of one knob that you turn in terms of deciding how Lambda is going to provision compute resources for you. And that's by the amount of memory that your function has available to it. So today, we now support everything from 128 megabytes all the way up to 3 gigabytes. And that was one of the other announcements from today. Now, with that memory knob, as you turn it, you also bring with it a proportional amount of CPU and networking resources. Previously, when we only supported up to 1.5 gigabytes, that would give you a full CPU core. Now with 3 gigabytes, you actually get 2 CPU cores behind the scenes. So for customers that are doing things like data processing, where they're pulling in big data files, or even things like machine learning, where they're bringing in big data models, this will be very useful from, again, more CPU and more memory. In terms of use cases, and we'll go a little deeper into this here in a moment, there's both synchronous and asynchronous use cases for Lambda, as well as stream processing, which we'll talk about. And then last but definitely not least on this slide, flexible authorization. So we think about security as being kind of the top priority for how we build products at AWS. It's not a bolt-on. It's something that we think about from the very day one of building a product. And so Lambda is definitely follows that model as well. So you have the ability to do things like put Lambda into VPCs and control the networking model around it. You have the ability to control who it is that can invoke a Lambda function, and then what it is that a Lambda function can do when it is invoked. When it comes to building Lambda functions and writing them, you can do it in basically any tool that you want. So whether you are a Visual Studio person, an Eclipse person, a VI person, an WordPad person, however it is that you want to write code, you can write code just like you've always been doing, and then basically package that up into a zip file today and send it up to the Lambda service. And we've got a number of third-party plugins that exist to help make this easier for you. Monitoring and logging is another thing that we consider a core tenet of Lambda and serverless applications. So we want to make monitoring and logging really, really straightforward for you. And so in Lambda today, if you want to create a log and have it centralized, all you do is output text. So you do the equivalent of a console.log or a printf statement or whatever it might be in the language that you're using. And what we do is take that text, capture it, and send it into CloudWatch logs so that you can very easily go and find that. We also have a number of CloudWatch metrics that we generate for you, so things like invocation count, duration, and then earlier today we announced a concurrency metric that goes along with a concurrency throttling capability. So a couple different metrics that exist there. From the programming model, so I already mentioned how the CPU and networking are aligned with memory, so you have the ability to do things like have threads, fork processes, interface with a temporary storage that exists on the underlying host that, again, is kind of abstracted from you. We today put our SDKs in for Python and Node.js for those language versions, but with Java and C#, you have to bring in the SDK as part of the packaging process. And then lastly, and this is one of the most important aspects of how Lambda works, is that it is a stateless service. So unlike if you managed an EC2 instance or you had a container running somewhere that was running for a long period of time, Lambda instances are incredibly short-lived compared to those. And there's really no such thing as affinity. There's no such thing as sticky sessions. So while you can store data in the temporary space, you have no way of assuring that when the next request comes in that you will land on the same compute resource that you had stored that data on. And so, again, very transient compute model, kind of comes and goes, and you never have to think about the underlying management of it. But when it comes to storing state, you want to do that someplace off of Lambda. So from a pricing model, again, we had said earlier that you never pay for idle with Lambda, and that's true. But how we actually bill for it is in the hundreds of milliseconds. So if you think about building an API-based service where your requests are typically maybe in the hundreds of milliseconds, maybe a second or two most, this pricing model aligns very, very well with these very small function-based applications that you're going to build, as opposed to a larger model, or even doing things that are second-based is too much for many Lambda workloads. Now, I talked a little bit about the execution model before. I'll go a little bit deeper here into what we support and how it works. So again, three kind of models for how you can invoke Lambda. The first is synchronous. So an example here is using API Gateway, where an API request comes into API Gateway. It's then going to invoke a Lambda function in response to that, take the response of that Lambda function, and reply back to you. And that's kind of in the model that you'd have with a web application or a mobile application where you immediately want that response. The second is an asynchronous version. So this is an example for S3, SNS, a number of other services where you're going to maybe send a message into a SNS topic, put an object into an S3 bucket, and then what's going to happen is those services are then going to pass the information about either the object and where it's stored or the full message from SNS into a Lambda function so that I could do something with it. Maybe it's going to take that object that was uploaded in S3, and it's going to use the recognition service to find out what that is in that photo. Or it's going to take information from SNS and put it into a database. And so in this case, you're not expecting an immediate response back from, say, S3 or SNS with whatever it is that Lambda is doing, but it's something that maybe your application is looking at later, or again, it's not the kind of thing where you need a synchronous response. And then lastly, the stream-based model, which today we support this with DynamoDB and Kinesis. What we have is basically a model where Lambda is pulling those services, looking to pull information off of them. So with Kinesis, we've got customers that are doing massive ingest of information, whether it be things like click tracking, IoT sensor data, collecting things like logging information in through Kinesis. And then what happens is across the shards that your Kinesis stream might have, we'll invoke Lambda functions against that, and it'll pull in those records and then process them for you. With DynamoDB, what we see people doing is using this for database triggers. So as records are written to a database, Lambda functions will be invoked for whatever business logic it is that you might have to do. And we've got a number of different services that have this integration. And actually, this is not anywhere near the number of them. It's much more just kind of an example of the grouping. And I think if I had to rewrite the slide after this last couple days, the total number of services that we have is well above 30 that can invoke Lambda. So we have data stores, we have endpoints, development and management tools, as well as our event messaging services. And there's all sorts of, again, different use cases and ways that you can invoke Lambda, again, going back to kind of the 6 main use cases that I talked about before. Let's go back and touch again on security with Lambda. So again, with Lambda, I had mentioned that there are a number of different ways that you can secure your Lambda functions, everything from controlling where it sits inside of, say, a VPC if you need to, as well as what are called execution policies and function policies. And again, the differences between these is that Your Lambda function is a compute resource. And so we give you the ability to assign to it an IAM role such that it could go ahead and say access a S3 bucket or a DynamoDB table or write to some sort of other service. Then the other is who can invoke that Lambda function. So unlike in a traditional web application where you are building maybe off higher up the application stack, what we can actually do is say the only service that can invoke this Lambda function is API Gateway, or maybe only Kinesis can invoke it. In that case, you're not dealing with the authentication and authorization between the two services beyond just what's built into how Lambda is able to take that. So you don't necessarily have to pass, say, authorization or authentication into Kinesis to then have it be able to invoke Lambda. It's just going to be part of the policy as it's configured. So you can get really, really fine-grained with these policies and lock Lambda down really, really tightly. Something that we also just announced today is in CloudTrail, there's a concept of data events. And so last year, we launched CloudTrail data events for S3. What this means is that we log the API calls for any time that you do a put or a get or a delete on an S3 object. What we've done now for Lambda today is announce data events for Lambda in CloudTrail. And what it now stores actually is the API call of the invocation against your Lambda function. So maybe you have a Lambda function that can be invoked by a couple different services. But you want to be able to look and say, OK, across these different services that could invoke my Lambda function, who has done it? When have they done it? Are there any potential maybe violations or the things that you need to tweak? And so from an auditability perspective, you can see kind of the full chain of activity that have happened from a requesting service into Lambda. Lambda is also going to have logs for every execution that it has. So you can really get a whole lot of information about your process in a serverless world these days. Now, Lambda is not the only product that exists inside of our serverless portfolio of products here at AWS. So Amazon API Gateway is another close kind of sibling of Lambda. And Amazon API Gateway is, just like it sounds, it's an API gateway. So what this is really useful for is fronting any sort of API that you're looking to build. And I've actually been recommending to AWS customers for years, even before we launched this, that you must have some sort of API gateway product if you're building APIs. And the reason I say must is because if you don't, you're spending development cycles doing things that API gateways have already built into them for you. So for example, things like authentication and authorization, caching, things like protection for things like DDoSes, things like data transformations. There's all sorts of things that API gateways do for you. And again, our API gateway is not the only one that exists out in the market. But again, if you're building an API and you're thinking about those things, you don't want to be developing that code. It's already a solved problem. So again, what API Gateway does is it allows you to have a unified interface across all of your APIs. Lots of different capabilities built into it, again, around authentication, authorization, caching, transforms. Earlier this week, we announced Canary deploys for API Gateway. So this allows you to have your new deployment receive a percentage of your overall traffic and then be able to roll that out or increase it or completely flop over to 100%. We have a couple different models for API Gateway. So the first, what we launched API Gateway with about 2.5 years ago was with what we call edge endpoints. These were endpoints that were fronted by CloudFront, our CDN service. So anytime you made a request to the API, it would go into CloudFront, into the API Gateway, and then into the backend. And this was really great, and is still really great for mobile applications, for things like web applications that are backed by an API. And then about maybe a month and a half to 2 months ago, we announced something called regional endpoints. These are endpoints that exist just inside of a region without CloudFront in front of them. This became much more useful for, say, traffic between services that existed just inside of a region, or maybe if you were exposing a service to other AWS customers that would also be inside of a region, or if you wanted to bring your own CDN configuration with you. And then today, in Werner's keynote, we announced VPC integration with API Gateway. What this now allows you to do is have a completely private backend to your API inside of a VPC, where your API is still exposed out to the internet, but the service that your API Gateway is in front of can now be private inside of your VPC, or it could actually be something that is private inside of your own data center, connected to a VPC over a direct connect or a VPN tunnel. And so there's lots of different things now that you can do with API Gateway in terms of, again, all the benefits that you see listed here and a number of others. Another kind of sibling product in the space that we have for serverless here is Step Functions. So Step Functions is a workflow management service for Lambda. When we first launched Lambda, what we saw a lot of customers doing was decomposing applications into very, very, very microservices. I actually just like to say it's a nano service model. And we'd have people having Lambda functions invoke other Lambda functions, have all sorts of business logic around how they would call one Lambda function or another. And so people were spending a lot of time putting code into their functions that was not business logic, but workflow logic. And so what Step Functions allows you to do is take all of that code that you would have had, say, again, in your Lambda function, and pass it up to it as a managed service. So in Step Functions, you get to set the layout for what a workflow would look like as part of a business workflow. So we see kind of here a very basic example where I have the start of my workflow. I have all the green boxes here represent a Lambda function. I'm going to extract some image metadata, and then I'm going to check what type of image it is based on the metadata, and then I have a choice that's there. And then I'm going to go down and store that image metadata, and then after this I can call recognition and create a thumbnail in parallel. After recognition, I'm going to add, say, tags to the object, and then my workflow ends. Now, all of the controls around what step happens next, if there had been a failure in these steps, so if one of these, for example, Lambda functions didn't work, Step Functions has the ability to do retries, exponential backoffs, all sorts of interesting things. So all that logic that you would have put into your Lambda functions to do this can now exist up at the Step Functions level. And now what this does is it means your Lambda functions become just business logic, no workflow needed. So that's pretty cool. So I'll talk about some other use cases that we have here. So Amazon Lex is one of kind of the key services that we have in our AI suite these days. And it's a natural language understanding service. So basically what it is you send it text, and it understands how to pull apart that text to be useful in things like chatbots. It's also one of the core technologies behind Alexa. And so when you have an Amazon Lex chatbot, there is this concept that's called fulfillment. And that's basically you've told the chatbot to do something, it's now going to do that thing. So when I say, Alexa, order me a pizza, the actual aspect of ordering the pizza is considered a fulfillment, and that's something that Lex will then go and invoke a Lambda function on. So if we want to kind of visualize this a little bit here, imagine that I had a chatbot or an Alexa skill or some sort of other voice bot, and I said, book a hotel in New York City. The speech recognition is going to pull apart those various words. The natural language understanding inside of Lex is going to say, okay, I have an intent of booking a hotel, and I know that there's some sort of information about it, which is that I want to book this hotel in New York City. That's called a slot. And so what can happen then is I have this intent and slot model, and what Lex and then Lambda will do is basically say, okay, there are other slots that I need to fill. And if there are, then it will come back and ask me for more information, such as when do I want to check in? When do I want to check out? And so a lot of that logic is handled inside of Lex, but then when it comes time to actually maybe save this booking somewhere, that's when Lex would invoke a Lambda function. And so this gives you the ability to build really, really powerful chat or voice-based interfaces, again, without having to run any servers, without having to worry about scale, without having to patch operating systems. Kinesis, which has a couple of different components to it these days, streaming, Firehose, analytics, and then we just launched streaming video processing earlier this week, has the ability to invoke Lambda also. And so we see customers doing a lot of near real-time data processing with this, sometimes in very, very high levels of concurrency. And so we can see an example here where I have an Amazon Kinesis stream, and streams can actually be processed by multiple different Lambda functions. And so I've got one Lambda function that's taking data off the stream and putting it into S3, and then I have another Lambda function that's taking that data off the stream and putting it into DynamoDB, and then maybe writing some metrics into CloudWatch or triggering an alarm if it sees that there's data that it considers bad. And so again, with this whole kind of mini architecture that you have here, no servers to manage, nothing that you have to take care of in terms of scaling, and quite a lot of capability in what can be done. So now I've talked about how you can interface with Lambda from various different services, but one of the other things that we see people doing is just working with Lambda in the raw. So it is an API-based service. You can call it directly at its API and do all sorts of interesting things. And what this has allowed some companies to do is build really sophisticated compute, distributed compute models using Lambda. So some really smart folks in UC Berkeley wrote a tool called Pyren, which does just that, distributed compute. What they were able to do with about 2,800 simultaneous functions is between 6 to 80 gigabit of processing power. This is a whole lot of processing power on a completely transient distributed cluster that they did nothing to configure, nothing to have to pre-provision or manage or install software on. And again, we're able to do some pretty impressive things. Lastly, one thing that we're really excited about this year is that we were able to get Lambda and actually almost all of the core components in the serverless suite covered by both PCI and HIPAA. So we already have a number of organizations in the finance world, a number of healthcare organizations building serverless architectures for everything from processing financial transactions to in the healthcare world where people are building things like IoT-enabled healthcare devices or even doing things like record processing, all while meeting kind of the compliance needs that their business might have. So where do you get started with this? So we've talked again a lot about the capabilities of Lambda, some of its sibling services, and how you kind of think about architectural aspects. But if you're completely new to Lambda and it's your day one using the product, where do you start? My advice is typically to find a framework that fits the need that you're looking for. So you could just go into the console, start coding, figure it out that way. But what we actually have is a really awesome ecosystem of partner companies as well as just open source projects that make it really, really easy to get started with Lambda. I even tell some of our more sophisticated customers that you should look at these frameworks because they just do so much for you. And I'm going to talk about two of them here. But again, there's a lot of different capabilities across all of these. So one of the ones that I'll talk about that's a pretty popular tool is called Claudia.js. As the name might suggest, this is a JavaScript framework. And so Claudia.js is really useful for building API-based applications. So again, that one bucket of a use case. And so we see here is basically about 5-ish or so lines of actual code. Some of it's kind of wrapped around. And then if I call the command that's down here on the bottom right-hand side of the slide, I will get an API endpoint. Now, I never need to go into the AWS console. I never need to click around or run the CLI. Basically, I can just write this into a text editor, call that command down below, and what it's going to do is configure API gateway, configure Lambda, configure all the IAM policies for it, and get this up and running. Again, with a very basic kind of /hello API call. But there's all sorts of capabilities around authentication, authorization, and more that can be done. Another framework, pretty similar though, is Chalice. Chalice is a Python framework. Actually came out of the AWS SDK team. And what they were doing was looking to build a tool that they could use to manage their infrastructure using Lambda and API Gateway internally. And they're very heavy Python users. They write and manage our Boto framework, which powers our CLI and a number of our other tools. And so they were looking for a really straightforward, simple Python framework. And so a couple of people on the team over a weekend actually whipped this up, and now it's a very popular open source project. So very similar to Claudia.js, what we've got here is about 5 lines of code and a command line that we run. And again, this is going to give us an API gateway, a Lambda function, all the IAM things that are necessary to glue this all together without you having to know how it works, without you going into the console, and without you having to get involved in some of the complexity that can exist here. So pretty cool stuff. Definitely encourage you to check it out. Now, what if you want to build a serverless application? You don't want to do something API specific. Some of these frameworks are specific to workloads. And maybe you actually feel pretty comfortable working with some of the more complicated features that we have in AWS. So we last year, actually right before reInvent, announced a tool called SAM. And this is our serverless mascot here, Sam the squirrel. You'll see Sam kind of in all sorts of presentations and things that we do. And actually, Tim Wagner, who's the general manager of serverless at AWS, kind of the godfather of this space, was actually running around Aria yesterday in a squirrel costume. So it wasn't just because he's strange, it was because Sam here is our mascot for serverless. So what SAM stands for is Serverless Application Models. And what this is an extension today on top of CloudFormation that also greatly streamlines what's necessary to build serverless applications. And so an example of what this looks like, and again, now what this does is nothing about our code. It's everything about managing the AWS resources. And so I won't expect you to read all of the lines inside of this, but really take away that there's kind of 3 sections to it. The first is just kind of a general header, and that basically defines what this template is. And then what I have are 2 different resources. The first is a serverless function, and then the next is what's called a simple table. Now the simple table is just going to provision a DynamoDB table with basic read and write units. And now with DynamoDB autoscaling, you don't have to really think about that too much. The serverless function, what this is going to do is define a Lambda function for me. And then a little further down, I have here an event structure, which is actually going to map to an API. And so when I take this template file, what it's going to do is configure, again, Lambda, API gateway, permissioning, my DynamoDB table. And since it's actually a CloudFormation template, I could include any other AWS resource that I wanted to. And so it becomes really easy to, again, have fine-grained control over how I configure the resources without having to maybe impact my code. Whereas a lot of the frameworks are actually a little bit more opinionated about how your applications are written. So just to think about this in another way here, what we have is roughly about 16 or 17 lines of code that generates roughly 6 different AWS resources, where if you were doing this in the console, you'd be doing a decent amount of clicking. Or if you were doing this on the CLI, you'd be doing quite a bit of typing of CLI commands. Now, just over this past summer, I think it was about August, we actually announced a tool called SAM Local. What SAM Local does is it looks at your code repository, it looks at the SAM template that's inside of that, and actually allows you to bundle all that up, and inside of a Docker container running on your local workstation, gives you the ability to mock and test a serverless application. So it can create kind of a FAW HTTP interface on your local host. It also has the ability to allow you to test the services that are asynchronous, so being able to do asynchronous invocations. And basically, again, gives you the ability to locally build, run, and debug serverless applications. So this is really pretty cool. And then just today, we announced AWS Cloud9. So Cloud9 is an IDE that exists inside of AWS now. And what this here is an example of a Lambda application that I have, where on the kind of center pane, what you see there is my Lambda code. But what's really, really cool about this, if you look on kind of the far right-hand side here, what I'm able to do is actually test the API for this directly inside of the IDE in near real time. So I'm editing my code, I hit test, I'm able to right away debug and get output of this function's execution. And so a lot of cool things you can do in Cloud9, definitely check it out. So with that, I'm going to hand it over to Nikki here to talk a little bit more about Capital One's experience in moving to serverless. So Nikki.
Thanks, Chris. Hello, everyone. My name is Nikki Joshi. I'm a director of software engineering at Capital One. I'm here to share our experiences about migrating one of our web applications to a serverless architecture. As many of you may know, Capital One is a top 10 US bank with assets in the tune of $350 billion US. As many of you may not know, is that Capital One is a financial institution on the cutting edge of technology. We are leading the pack in the move to public cloud, and AWS is a strategic partner in this process. According to Alexa.com, our primary website, CapitalOne.com, is a top 100 US site in terms of web traffic. The story I'm going to share today is about our experiences of migrating our Capital One auto finance marketing site to a serverless architecture. Our story starts in 2015. 2015 is when we started to migrate our systems over to AWS. For our Capital One auto finance site, we broke the journey up into 2 phases. The first phase went live in August of 2016, and we completed a serverless migration in April of this year. Before starting the migration, we took a step back and looked at the holistic requirements of a marketing site. We obviously had to migrate the full functionality of the site, as well as have advanced capabilities like multivariate testing and A/B testing built in. We are a financial institution, so security was obviously key for us. We had to be set up in a resilient, active manner. This is a marketing site, so the response time had to be very low, and we had to be set up in an SEO-friendly manner as well. We had to be set up in a low maintenance mode with the capabilities for continuous deployments. And we didn't want to reinvent the wheel. So there were a lot of existing tools and processes in the organization that we wanted to reuse, primarily around logging, monitoring, and deployments. This is the architecture that we started from. The architecture here is not very different than what many web applications have even today in enterprises. While there are many challenges with this architecture, there were two issues that were highly limiting for us. The first was that since this is an enterprise-wide common deployment, there was one release calendar that dictated our release cycle. As a result of this, we had to sometimes have our code developed months in advance before we could release it to production. Obviously, that's not optimal for a marketing site. In addition to that, this is a highly tightly coupled architecture. There are times when there were issues in one part of the application that were causing issues in an unrelated part of the application as well. Obviously, that's unacceptable. So with that, we started our serverless migration. And in phase one, we accomplished two objectives. The first was we moved from on-premises data center over to AWS, and we created our serverless content strategy. This is the architecture that we came up for our serverless content. For our application, we chose a single-page application framework. Angular was our choice of framework for that. We created a pre-rendered bundle of the application and deployed that in an S3 bucket and leveraged S3 web hosting. We replicated that content from S3 in the East region over to the West region. Both S3 buckets were fronted with CloudFront, where we hosted our SSL certificate for SSL termination. CloudFront was fronted by Route 53, which gives us our resilient active-active setup as well. In addition to that, we were able to leverage a non-AWS component like Akamai at the edge for content caching. To summarize, I would like to call out 3 points in this architecture. The first is by leveraging S3 web hosting, we were able to eliminate the need for any EC2 instances. By leveraging CloudFront and Route 53, we were able to meet our security and resiliency requirements. And finally, we were able to leverage a non-AWS component like Akamai as well in our architecture, which allowed us to continue to leverage our investment in Akamai as well. This is the architecture that we landed on for our APIs. Now, our target state was always to go serverless. However, we ran into a few issues internally for us to be able to use Lambda functions in production in 2016. As a result of that, we had to come up with an alternate EC2-based architecture. The first two EC2 instances here are running Apache with security configurations. They're acting as a web application firewall. The two EC2s in the back are running Tomcat with the application logic. Both clusters of EC2s are fronted with load balancers. This setup is then replicated across 3 availability zones in the East region, and then the entire setup is then replicated again in the West region. Both regions are then fronted with Route 53 for a resilient active-active setup. Now, for the functionality that this application has, this definitely seems to be a lot of infrastructure for that. So in our phase 2 migration, I'll talk about how we migrated this over to a serverless architecture. Wrapping up our phase 1 migration, this is the CI/CD process that we built for our content. We store our Angular application templates in GitHub. We store the corresponding content in a CMS system. We have an EC2 build server that pulls the templates, pulls the content, packages them together, and creates a pre-rendered bundle of the application. Leveraging the AWS CLI, we then push that bundle into an S3 bucket for web hosting. This gives us 2 advantages. The first, it allows our application to be responsive, and it solves the SEO issue that Angular typically has as well. Coming to our phase 2 migration, this is where we were able to migrate our APIs over to Lambda functions, and we created our CI/CD process for our Lambda functions as well. This is our architecture that we landed on for our APIs. The Lambda functions in the front are the ones that are hosting the application logic. They are also logging to CloudWatch. Since our target enterprise logging infrastructure is Splunk, we needed to find a way to be able to get the logs from CloudWatch into Splunk. For that, we were able to leverage another Lambda function, which is triggered with logs in CloudWatch, and that basically takes those and puts them into Splunk. If you look at the diagram at the front, you'll see something called the Capital One Enterprise Gateway. That's very similar to the AWS API Gateway that Chris talked about earlier. Since we already had an API gateway internally, we chose to leverage that and hook up our Lambda functions to that gateway instead of the API gateway. So to summarize, I'd like to call out two things here. By leveraging the Lambda functions, we were able to eliminate the need for any EC2 instances for application hosting. And we were able to leverage non-AWS components like Splunk and our Capital One Enterprise Gateway in this architecture in a seamless manner as well. This is what we built for our CI/CD process for our Lambda functions. Jenkins is our enterprise build tool of choice. We store our Lambda function code in GitHub, which triggers a build job in Jenkins. The Jenkins job takes that code, utilizes the AWS CLI to create a deployment bundle and stores that in S3. By leveraging functions like Lambda create and Lambda update, we were able to create and update our Lambda functions accordingly. Other options that we looked at were the serverless application model and the serverless framework that Chris talked about a little bit earlier. For us, those were a little bit of overkill because what we had was something pretty simple, and this sufficed for what we were looking for. So with that, these were the benefits that we saw. We landed up with a very super simple architecture. It pretty much runs itself. It scales itself. We have no worries on AMI rehydrations anymore, which is keeping our compliance and operations teams extremely happy. And finally, cost. As a result of this migration, we saved about $50,000 a year on a conservative manner. We were able to leverage S3 web hosting and run our functions in Lambda, and as a result, we were able to eliminate about 20 EC2 instances, EBS volumes, and load balancers from our architecture. Also, we were able to save countless number of hours in terms of operations and managing infrastructure, which is a big plus. Finally, coming to our lessons learned, migrations can be a journey, so I would recommend to plan accordingly. Start small. Look for the easier parts of your application to migrate first, and then go to some of the more complex pieces. There's no one-size-fits-all. Serverless architectures are very flexible and fungible. As I've demonstrated, we were able to mix and match components and utilize non-AWS components pretty seamlessly as well with the architecture. Try to reuse tools and processes that you already have in your organization. Don't try to reinvent the wheel. And finally, I would recommend to get your stakeholders buy-in early. You'll have folks from architecture, security, operations that you will have to involve as part of the migration, and you'd want to keep them involved in the process, and I'm sure that they'll be very happy to be a part of the migration. So that concludes my piece that I had in our experiences at Capital One. So thank you so much, and with that, I'd like to hand it back over to Chris to wrap up the presentation.
Thank you very much, Nikki. So a really straightforward, at the end of the day, kind of example of something very complicated, right? A transition from both on-prem to the cloud to serverless, where money was saved, time is saved, resiliency is increased, scalability is increased, all by this move to serverless architectures. So just kind of a couple of kind of key takeaways here in closing. Again, when we talk about serverless here at AWS, a couple of key factors that define the space for us. No servers to manage at all whatsoever, whether they're, again, physical, virtual, or even containers. No cost for idle. Automatic scaling built in. High availability built in. All important key things these days. Kind of 6 big buckets for use cases. Web applications, backends, data processing, chatbots, Alexa, and IT automation. And then a number of services that can be used to invoke Lambda. You probably surprise yourself if you stumble upon it in the console, the ability to pass in a Lambda functions identifier in response to some sort of an event. So if you're using any of these today, it might be interesting for you to take a look at just what it is that Lambda can do to help simplify it. Now, a lot of the things that we talked about today are actually covered on the new serverless landing page. This just was refreshed this morning. One last thing I want to talk about from a getting started perspective is we also announced today the serverless application repo, which is in preview mode, but coming out here hopefully pretty soon. You can sign up for that preview as well and should get access here in the coming days and weeks. But beyond that, what we have off of this page are a ton of resources for getting started, a ton of things for reading and learning more on. We actually just released 2 serverless white papers in the last couple of weeks. Links to our compute blog, to all sorts of things. So head to this URL if you really want to get deep into this space. With that, my name is Chris Munz. Again, I'm a senior developer advocate for serverless at AWS. I can be found at munz@amazon.com. I'm always happy to help people figure out things. You can also yell at me on Twitter at Chris Munz. And again, thank you very much for coming. Please provide us feedback on this talk. We greatly appreciate it. Have a great rest of the time at reInvent. Hopefully you enjoy the replay party tonight. And again, thank you for coming.